This is the Early AI podcast hosted by Seth Earley. Join us as we delve deep into the passions, expertise, and experiences of thought leaders and practitioners to talk about what's possible with artificial intelligence. The Early AI podcast is sponsored by Early Information Science, your digital transformation journey with design and deployment of innovative technology solutions, as well as Vector. Now enjoy the show.
Welcome to today's Early AI podcast. I'm your host, Seth Earley, and in each episode, we explore how artificial intelligence and data are reshaping business strategy and operations. Today, we're talking about one of the most persistent obstacles in enterprise AI, the gap between where data lives and where AI needs it to be. And so joining me today is Todd Barr, CEO of Axonis, a company that was spun out of a governance defense integrator and is now bringing federated AI and decision intelligence to high consequence enterprise workflows. Todd has been a part of major infrastructure shifts at Red Hat, Ansible, GitLab, and Chainlink Labs, and brings a pattern recognition perspective to what may be the defining infrastructure shift of our era. So Todd, welcome to the show.
Thanks, Seth. Thanks for having me.
So we like to start with common misconceptions. And what are you seeing as the biggest misconception that executives have about AI readiness and the role that data architecture plays in it?
Yeah, good question. So I think the misconception starts with how easy it is to make a really great demo today. So Claude makes it super easy to show an executive something that looks real, feels real. You can click on it. It looks like their data. And in fact, it is real. It's just not actually connected to anything. And I think the misconception, it's a little bit almost malpractice, I think, what we're doing, which is getting people excited about something that they can't have necessarily, because all of these things rely on access to their data. And if you're in an enterprise, that's not a non-trivial thing. So I think the misconception is really sort of the gap between, prototype and reality. And that's where a lot of these things are falling down right now.
Yeah, I couldn't agree with you more. I call it the pilot paradox, right? It's the pilot looks great. People like it. They say, give it to me. This is what we want. And then many times the pilot, a proof of concept or whatever you want to call it, is made with highly crafted artisan treatment of data, and it's lovingly curated and filled and so on. And then you have this limited data set that is pristine and pure and wonderful. And then you try to go to production and it's just not there.
Right. And then I think that builds on the next misconception, which is then the consultant says, well, it's great. You just have to connect it to your data lake or your Snowflake. And that's not exactly true either. And I think what we're seeing is that, there was this Snowflake is here for a purpose. It went crazy and everybody loves it for certain reasons. But, some of these things were made for an era of business intelligence, not artificial intelligence.
Right.
And there is a difference, right? When you put your data in a Snowflake, you are sanitizing it, you are normalizing it, you are cleaning it, you are syncing it, right? And it's optimized for quick reporting, not optimized necessarily for reasoning or for making predictions and outcomes based on your data. So you have, that's sort of the next layer of misconception is that you can just connect to your centralized data. The other misconception is that everybody has centralized their data. The truth is nobody has centralized their data. You may have some centralized data. Congratulations. You may be in the middle of a multi-year data centralization and normalization project that never ends. Congratulations. But you have not centralized all your data, and some of your most valuable production data hasn't been centralized.
And, I think centralization in itself is a fallacy because whenever you're using data, you're changing it, you're enriching it, you're doing something with it. And when some part of the organization operates on data, now you have to sync it back and say, is this still the source of truth? What's the source of truth? If two different parts of the organization need to do something with data and they operate on it and they're going to change it or they're going to produce another output or they're going to adjust it in some way, well, now where's the source of truth, right? So I think that just the very fact of decentralized processes, right? Because not everything is centralized. You have different leaders, different business units, different technology initiatives. They're experimenting, they're doing things, they're trying new things, they're trying campaigns. All of that is touching the data, changing it. So it's almost this fractal nature of data and these data changes that defy the whole concept of centralization, really.
Yeah, it's almost by design too, right? The data you've centralized is a different purpose than the
Right.
data that is out at the edge of
Right.
your enterprise or of your organization. And so it's almost by design, but I think that sort of just unpacks this fallacy, which is centralization is not the answer to AI
Mhm.
readiness.
Right.
And that's
Right.
really, to me at the core of where the problem is
Mhm.
today.
Yeah. I mean, it by its nature, it's always being applied and transformed, and you can have centralized reference data. Right? You can say,
Yep.
here's some values of, here's a product master, here's a customer master, here's certain processes that will require a source of truth. But then when you're actually putting it into production and operationalizing it, the nature of the beast is that it's constantly transforming, it's constantly evolving, it's constantly changing, it's constantly shifting. And that's the data that you want to really operate on, right? That's the stuff that is meaningful to the organization.
Yeah, and I mean the whole premise of agents is that agents go out and do work for you, and they are and can be autonomous, right? So if you have to centralize and sync data before the agent can act on it, you're missing the point. The whole idea of an agentic approach is decentralized. And
Mhm.
so you're sending agents out to do work for you. You're sending AI out to do work for you. And so I think you really need to start thinking about, okay, how is the agent going to interact with my decentralized data? And what do I want? What's my business outcome of this? If is it a
Mhm.
prediction that's happening during a transaction? Is it a fraud check? Is it some business process that needs to be kicked off when we see some data from a sensor somewhere? So you really have to understand those business processes. And I think the whole concept again of agentic is you're decentralizing
Mhm.
your workflows into
Mhm.
agents that can go out and do stuff for you and then communicate. I think that's
Mhm.
driving even more down this road of centralization isn't the right architecture for this.
It's just conceived the conception of it is just wrongheaded. That was kind of my next question, but we've already answered it. It's like the centralization fallacy. The idea that they're spending years building data warehouses and lakes, and that's the wrong foundation for AI. So when you look at it that way, what actually needs to change, right? Because they've made all these investments in that infrastructure, in those efforts. They have that. There's certainly value for certain processes, but what else has to change?
What needs to change? So first of all, I think we don't want to throw away the work. Like I said,
Glad you
plus
didn't say baby with the bathwater. My wife hates that phrase, and
I
she's
didn't.
trained me to hate it. So
Yeah, we don't want to throw away the work. I think ultimately some of that work is to be reused
mhm,
for, like you said, the right use cases, right?
mhm,
I think there's a lot of great use cases for using AI to rapidly create better BI type workflows,
mhm,
and the centralized clean data will be used for that for sure. Building models on top of clean data, like there's some benefits to that, but it's
mhm,
not the only thing you need to be doing. So what needs to change? I think the mind shift is I'm going to
mhm,
send my AI to my data instead
mhm,
of bringing data to my AI. And that's kind of the big mind shift. And we talked about it originally in this call from an agent's perspective, but in general,
mhm,
AI execution
mhm,
needs to happen where the data is.
mhm,
And that's the thing that needs to change from a thought process perspective.
mhm,
And that's a big change because most people are used to this concept of centralization first. And
mhm,
so that to me is the thought process is like, what does AI execution look like when it's happening at the edge or where the
mhm,
data is? What do you need to think about from a data perspective when it's there? And then
mhm,
there's a real architectural question. It's like, how does this work when you're trying to send AI to the data? Who owns the data now? What is the AI allowed to do? What is the
mhm,
security?
mhm.
Where is
Yeah.
the security? I mean, we can
Where's the
talk about
provenance
mythos
of
in a
that
minute,
data?
but where is
Mhm,
the security? Is it in the
mhm,
perimeter? Is it somewhere else?
mhm.
These are all the things you need to start thinking about when you're thinking about moving the AI instead of the data.
And you make a very good point about the use case, right? Because there are perfectly good cases to bringing something together. You want a knowledge repository of all your procedures and all your guidelines, right? You need to have that. You can't if you have knowledge fragmented all over the place, it doesn't make sense. If you have product data fragmented all over the place, it doesn't make sense, right? But there are certain situations, so it's really use case dependent, right? And
Yeah.
and we do want to say I need to go and get this data where it's fresh, where it's living, where it's breathing, where it's on the edge, where people are interacting with it, where the value is being produced, rather than wait for it to go into some repository and some magical process that's going to make it beautiful and wonderful and, reach data quality nirvana, which may not be necessary, right? But it is dependent on it.
It could resist centralization for what you just talked about, which is sort of a use case, which is a transaction or something like
Mhm.
that, where you really want, you don't want to have to wait for the data to be synced and transformed, synced and centralized to make a decision. So that's one kind of reason. Another reason could be that the data is sensitive data. It's PII, it's
Mm.
HIPAA data, it's GDPR data, and there's now a cost more than
Mm.
just moving it.
Right,
There's a compliance cost to
right.
moving that data and having multiple copies of
And
it
and risk and
and
risk,
risk, right?
no.
And then another example is data that is expensive to move because it's big, right?
Mm,
Video data, or other data that's being created out at the edge from
mhm,
sensors or at a factory floor or something like
right,
that. And it's like, well, I,
sure.
I don't really want to move all that data and pay
No.
for that in the ingress and egress. So
Mhm.
there's sort of bandwidth slash cost issues. It's really just a
Yeah.
cost issue of is it
Yeah.
worth it? And then the last one is data that is organizationally um, resistant to movement. Now, that could be a social problem inside a
Mm,
company. You have an IT organization where you have application owners and they're like, this is
mm.
my data, right? And so it's politically hard to move. It could
Sure,
be that you actually
sure,
want to,
yeah,
yeah, it could be that you actually want to do things outside of your organization. And
yeah.
so you can't share your data outside the organization, but you
Mhm.
still need to do some intelligence sharing or something. So now there's real kind of organizational barriers or other things. So that's what we talk about when we talk about data that's resistant to
Mhm.
centralization.
The other thing, we had Stephen Wu, who's with Rambus memory technologies.
Yep.
And one of the things he observed is that the highest power consumption is from data movement, right? It's
Oh,
not
that's
from
interesting.
the
Yeah.
CPU. It's from getting data in and out of memory and getting it from across and from longer term memory and from sensors and from collections. All of those movements are the biggest cost for in terms of power. So people don't realize that there's all this hidden stuff. And in terms of memory moving things in and out of memory, moving things from one device to another, moving things from the peripheral and from distributed sensors, all of that is very power intensive. So that's like just a practical reason to say you don't want to move all that data all the time because it's costly in terms of power in addition to other constraints.
If you think about the fact that at least in the US, in the West, we're power constrained when it
Oh
comes
gosh.
to inference,
Oh
right?
yeah. Yeah.
And the growth of AI. So that's really an interesting insight. It's like, what are we going to use our power on? Wouldn't we
Yeah.
rather use it for reasoning and
Yes.
training the much better models than moving a bunch of data around?
I wish I had read a Scientific American article like the next day after I interviewed Steve, and it was about new types of magnetism and new, like there's a third kind of magnetism. I don't know all the details, but the implication for memory is incredible density and incredible energy savings, like orders and orders and orders of magnitude that are going to change the dynamics and change the economics of data centers of everything. Now, it's still like 10 years away from anything
Yeah.
that's commercial, but it's like the stuff that you don't realize that's happening at a basic research and development in a very scientific, principled way, very fundamental way that are changing things into the future. It's
Well, I think this is
fascinating.
an interesting topic just relative to global kind of competitiveness too.
Yeah.
I think China is obviously innovating quickly in the AI space and they are power wealthy, right?
Yes.
Whereas we're
Yes.
power behind in our
Yes.
infrastructure. They're power rich, but chip, kind of GPU poor, right? And
Mhm,
we're
mhm,
like the opposite.
mhm.
And the question is, what's going to happen from an innovation perspective? And I
Yeah.
think we're actually already seeing it because in China, what they're doing is they're coming up with these really powerful quantized and MOE models, and they're really innovating around how those models operate from an architecture perspective. And then they can throw a bunch of power at it. I think it's just going to be an interesting to see how
Yeah.
the resources at the ground
Yeah.
level basically are what determine where AI is going in these different regions.
Yeah, yeah, and whenever you're coming up across physical constraints or constraints around when I say physical, like the physics right?
Physics.
Like
Yeah.
photolithography or X-ray lithography and things like that. I saw a fascinating video on the whole X-ray lithography development life cycle over 25-year period. A company called Vertasium that does these videos, and it's like this is the most complex machine in the world, and it was for X-ray with lithography. And anyway, but we're always innovating beyond what we think is the physical limitation, which is what's so fascinating, and it's
Yeah.
almost an endless cycle of innovation and capability.
It is. Yeah. And I think we're seeing that play out weekly
Weekly,
in
yes.
AI, which is
Oh,
why it's
yeah.
so hard to keep up.
It really is astoundingly fast. What federated AI means, when you say what does it mean when we talk about sending the models to the data rather than bringing the data to the model? What is that approach why does that approach matter
Yeah.
for regulated, distributed environments, and what does it really mean to do that?
Yeah. So there is a kind of a topic called federated learning. Federated learning has always been very interesting to, AI PhDs, right?
Mm.
They're like, I can take a model. So most model training relies on a centralized data source, is the way to think about it. I'm going to run a model training job, and the model training job's like, where's my data? And
Mhm.
you point it to the data and boom, it starts training, right? Federated learning is essentially math that allows you to break up that model and send it out to distributed data sets
Mhm.
and then bring back the weights and measures and parameters of that model and reassemble them into a better model because you can get access to more data. So the whole concept is I can have better models by skipping the centralization part, by having the opportunity to be able to send my model out, do some training, and bring it back together. That's federated learning. And there's multiple types of federated learning based on what you're trying to accomplish. What we found is that federated learning is interesting, but a very small set of use cases right now. It will be important, but the problem is you need federated or distributed data and you need access
Mm.
to it to
Mhm.
make federated learning useful. If you don't have access to distributed data, then federated learning is sort of just sitting there waiting for you to get access to it. And so we ended up spending a lot of time on how do you get access to federated data? How do you get the data access to be able to send the model out to it? And what we realized is a couple of things is that one is this problem comes up more when it's cross organizational. So you see a lot of kind of these world models. They want to train a model on data that is, can help the world. Like think cancer diagnoses. If we have more data to train a bigger model, we can find cancer faster, as an example. And that's true across a lot of different types of domains. It could be any sort of social problem that if you had just more data from governments or others and you could train a better model, then you could get better outcomes for that. And so we thought, hey, well, if that's really where where the big unlock is, we need to make it possible for people to share intelligence and train models without sharing their data because they're never going to share their data. It's
Right.
too political, right? A hospital
Right.
system isn't going to share their data with another one, likely. And the same true is in government, even inside of the US government, for example, where we operate a lot, organizations don't share data, right? And they don't want to because they're kind of competitive about it. But if we could make the unlock of you can share intelligence and you can train models, but you don't have to
Mm.
share the data,
Right.
then that would be a big unlock. And so
Right.
so that's what we worked on. It was like the
Huh. Yeah.
federated data
Yeah.
layer. And so the combination of those two things is what we
Mhm.
call federated AI. It's you can send the model out. Not only that, you can send inference out so that you
Mm.
can actually infer where that data is being created. And you have access to this data in a distributed way that's secure and you don't have to share.
So that's kind of fascinating when you think about this idea. We just talked about the different reasons why data resists centralization, and their technical reasons we
Hmm.
talked about, their regulatory reasons, right? Some of those agencies can't share their data, right, for whatever reason. And there are political reasons, right? As you mentioned before, you said there's proprietary or ownership or turf battles or whatever,
Yep.
hey, it's my data, it's my application. I can't share it with you for whatever reason, whether it's required or not. How does that federated architecture address all three?
Well, I think it would be good to know where this came from. So you mentioned that we, as a company, had spun out of a government solutions integrator. That government solutions integrator happens to operate in secure environments. And
Mm.
so if you think about those environments, you often you deal with the problems that you just talked about. So
All three, yeah.
yeah, so one is the technical problems, right? You have to be able to go offline and come back online and resync, right?
Mm.
So you have to be able to operate in what's called a the DDIL environments, right? The distributed environments where that might be disconnected and
Right.
intermittent and those types of things. So that's one area that you have to be able to do if you're going to do this approach. The second thing is the security has to be applied at the decentralized node level,
Yep.
because if you're solving the social problem or the organizational problem, they're going to want to control what
Hmm.
happens to their data. So you have to solve the data security problem at the data where it's being connected. And so we solve that. We have this thing called attribute-based access control that, you can basically add policy to your data down to the cell level. That security then has to be obeyed throughout the
Hmm.
federation that you create. And so it has to apply to the model training. It has to apply to
Hmm.
inference. It has to apply to just role-based access control and what your data
Hmm.
scientists can see. And so that's kind of how you control it, is you actually go down to the atomic node level and you say, whoever owns the data gets to control the access to the data. And we've set up a system that does that, and then it obeys it. So one example that I like to give is, let's say you're in a US government top secret environment, right? And that means you have people who can see top secret things. Then you have people who can only see secret things. And then you have people who can only see confidential things, right? So you have these levels. Well, you have data that's classified at those things as well. And you also have models classified at those things. So if you are a person who's classified top secret, you can set off a model training of a top secret model on top secret data. But if you are a person who can only do confidential, you will never see the top secret models and you will never see the top secret data. You will not even know it exists in our system, right? You can never train a secret model on top secret data. That wouldn't happen. The secret model would not even know the top secret data exists. So that's a very specific
Yep.
example. But it's really important to understand that the security is handled at that decentralized level
Right.
where the owner of the data is.
Right. Right. And I imagine there's a good bit of complexity to that, and it has to be well defined and well modeled and then applied and operationalized. So there's certainly, it's not trivial to build, role-based access control and attribute-based access control, right? You're really doing it at a very granular level, which can get very complex.
Yes, absolutely. There's management there. There's data policy work to be done
Hmm.
there. And of course, if you don't want it that complex, you can certainly, bring it up a level and
No,
just do it at the
no.
document level or have different
Right.
less granular controls. But I think the important takeaway is that this builds a foundation for AI, and it doesn't have to even be federated for this
Mm,
foundation to be interesting. I was
mm,
speaking to a head of AI at a bank who's trying to figure this out, and theirs is more of the social problem. They have these
mhm,
application owners. So I
mhm,
said, hey, you can give them the opportunity to control access to their application and their data for your AI initiatives.
mhm,
And that's a way to do this, is you can actually delegate authority down to the
mhm,
the data owners for how their data gets consumed with AI. And that was a really compelling
mm.
architecture for even inside of an enterprise, right?
Right,
Where there's
right,
politics and data
right,
owners.
right. That's great. So we talked a little bit about decision intelligence and decision artifacts.
Yep.
So tell me what a decision artifact is and why does capturing AI-assisted decisions as structured, auditable data matter for these high consequence workflows? And we know we need to have auditability, we need to have traceability, we need to have accountability, we need to make sure that our models are not drifting, right, and that they are producing accurate, precise, well-grounded, well-cited information. But tell us what this artifact is, this decision artifact, and how it kind of encapsulates that decision making and those that at that atomic level, or
Yeah,
whatever
sure.
level is appropriate.
Yeah, thanks. Thanks for the question. Just kind of how we got here. Once we had this federated AI layer, we were like, why are we doing this? And the
Hmm.
truth is, people are making decisions now with the help of AI, and they want to do more of that because it speeds decision making, and they want to eventually have agents doing it. So we started to think, wow, we actually sit in the perfect place where we
Right.
can capture everything that's happening across their data and the decisions that they're making infusing AI. What you were talking about was compliance planes. So for example, these, you know, AI Act and other similar acts are creating the need for human oversight, record keeping and traceability and auditability, and even
Hmm.
monitoring after that. I think a lot of people are thinking about traceability as, what is the AI doing itself? So, model compliance. And model drift and
Right.
model bias and all those things. And that's
Uh-huh.
important. But the whole other side of that is, what are the humans and the AI doing together, or what are the agents doing by themselves? And we call that the decision plane for compliance. And
Mm.
so we have created a standard called decision evidence specification and implemented that standard, which is, how do you track AI that's
Mm.
working with humans or by itself to make decisions,
Mm.
which is basically what everything's happening in business is. And so it's, what is the data that was used? What is a snapshot of the data that was used at the time that the data was used? What
Mhm.
was the AI model or LLM that was used to interact with that data? What did the chat look like that the human had to
Mhm.
make sure that we understand kind of how the human was thinking through the reasoning?
Mhm.
Did the model hallucinate and start to use data that was outside of the data space that's
Mm.
approved? We can tell that. And then finally, like, what decision was made with all of that? And then
Mhm.
we can capture that as a cryptographically sealed data artifact. And now you are creating a database of all of your decisions.
Right.
And then once you have a database of your decisions, you can train a model on that and you can make better decisions next
Right.
time. So it's a whole new category, to be
Mm.
honest, is, I'm going to call it
Mm.
decision observability, if you will.
Right.
And it's a whole new data set that's being created as people interact with LLM. So I think
Mm.
2 years from now, we will have customers who will have built up this decisions artifacts that's now a corporate asset for them, right?
Yeah.
It's how their
Yeah.
company works. Does that make sense?
It does, and you're building objects that incorporate, uh, all of the factors around that decision, how it was arrived at, how what the context was, how the model made that decision, and you're bringing that together and saying, "Let's make sure that this is an immutable object. We
Correct.
don't wanna go back and make changes to it. We wanna make sure that there's that auditability and that it's
Yep.
not
It's a
exposed
ledger.
to" right? So that's interesting, and then I could see how you could do retrospective analysis on that to say, how accurate were these? How did these decisions bear fruit or not bear fruit, right? How did they impact downstream processes? What's the historical track record of these decisions and these models with
Yep.
all of these other parameters? And because right now it's kind of like gone. You don't really have that all of that context, right?
I mean, in every company I've worked for, there's not a place where decisions were recorded other than
Right.
some like board meeting notes, right?
Right.
Or,
Right.
OKRs, right?
Yeah.
Or
Right.
something.
Right.
It's not a it's not a deterministic system, right?
Mm.
It's or a database. It's a,
Mhm.
oh, what did Johnny do last week and why did you make that decision, Johnny? And so I think it's a whole new possibility of like
Mm.
turning your decision into this flywheel that allows you to make the next decision even better, right?
Right.
The faster you do this. And we're
You
going to
course
need this
correct.
with agents from an auditability perspective as well to just see. But like, imagine you could just say, hey, after let's look at our last 100 credit worthiness decisions, and let's have half of them use OpenAI's latest model and half of them use Anthropic's latest model.
Mm.
And then we'll see which ones make better decisions, right?
Mm.
Or
Mhm.
guided the humans in different ways, right? There's
Mhm.
all kinds of really interesting, new data and insights you
Mm.
can get from the concept of having, decisions as data. And I don't
Right.
think it was possible before AI. Now we want it because we want
Right.
everything to be programmed. It's sort of like a new opportunity for us because we want to infuse
Right.
AI into everything.
And I can see how you could have that decision artifact library that would be kind of like a knowledge base. It
Be-
could be tagged in different ways, right? It's a repository of this historical decision making with all the different parameters, with the inputs, with the outputs, with whatever that model was, and taking a snapshot of what that was, and then judging those decisions retrospectively by saying what was the outcome, what was the accuracy, was the prediction correct, was the direction correct, and then how do we course correct from here, right? Was it
Yeah.
good? Do we just want to do more of it, spin the wheel faster? Do we want to change it? Do we want to use a different model? How do we compare the outputs?
Yeah. It's a really cool set of use cases that
Yeah.
possibilities you could think of when you have that data.
Absolutely, and you have that mechanism. So you talked about this in the beginning, the demo to production or pilot to production gap, and we know that is kind of a disservice to executives because it doesn't give them an accurate picture of what it really takes. And sometimes when you give them an accurate picture of what it really takes, they're like, "Whoa, wait a minute! I don't know if I want to go down that path." I'm doing an ROI model for a PE company right now on product data, and like, yeah, product data will give you this much, but product data plus you know, content processing and content operations plus knowledge operations plus, data models plus
Yep.
all these other things will give you that much, right?
Yep.
But it's probably 5 times the investment you want it to make, but it's going to impact your valuation by a factor of 10. It's so disproportionate. It's incredible. But how do you get over that? Because executives have been burned, right? I mean, obviously they've been burned a lot and they're getting burned a lot in this AI space. So how do you communicate that realistic path to what production really requires without like scaring people off? Because I think, automatically there's a discounting of what you're saying, right? Whatever the promise is, right?
Yeah.
Whatever the assurance is, whatever the estimate is, it's like, it's going to cost it's twice as much. You're going to get half the value and it's going to take 2 or 3 times as long, right? So there's automatic discounting. So how do you kind of map out that realistic path when you think about it? What are the decision-making factors that have to go into that?
Yeah. So I'm going to throw one more wrench into the problem, which
Please.
is that
Why undercomplicate when you can overcomplicate?
exactly. I just got the email literally today from Microsoft about Copilot moving to consumption model. So everybody's moving to tokens now,
Mm,
and you're
mm,
going to be counting tokens, and
mm,
nobody knows how many tokens are actually going to be
mm,
used for these use cases. I can tell
mm.
you I'm down the rabbit hole of my own AI. I have
Yeah.
a NVIDIA GB10 sitting here that I am running models on and trying to optimize tokens. Have it fall back to Claude, and then I'll have a $200 day. And I'm like,
Yeah.
uh-oh.
Yeah.
And so there's a whole new wrench in the situation, which is
Yeah.
nobody knows how to size these things from a cost
Right.
perspective. Hopefully we're going to figure this out. But if you're an executive right now, the temptation is to say, you know what? I'm just going to give it all to OpenAI and let them solve my problem, or to one of these, big trillion-dollar firms. And I think that's not the right answer. What are the 3 things to think about? So the first one is you need incremental solutions. You need to solve a problem and you need to be able to add to that. And so from a data perspective, it's like, what's the first data source that you could really use some insights in to?
Mhm.
Let's solve for that. Then let's add another data source. Then let's add another use case and some more users to it. So I think you need solutions that are incremental and
Mm,
allow you to build, right? Not wholesale architecture shifts. And I
mm,
think we've seen that if you can come up with incremental, you eventually can move your architecture into something that's
mhm,
better. The
mm,
second one is you need optionality.
mhm,
So by committing to models, for example, you start to lose optionality. So if you
mm.
were just to give your whole AI strategy to one,
Yeah.
you're probably losing optionality in the future. And so keep your optionality. Use gateways. Find ways to build into your enterprise architecture the ability to change models and change vendors. And then the third one is be thinking about owning your own AI at some point. Models are getting so much better, so much faster, and there's
Mm,
open source is driving a lot of this innovation. There will be a world where in 1 year, 2 years, 4 years, you will want your own models running. And so start building towards where you can control your own costs on a
mm.
CapEx perspective rather than everything being OpEx and going out of control. So those are the 3 things I would say at the highest level if you're a C level is start incremental with real use cases,
Mm.
build optionality in, and then in the future be thinking about how you're going to own as much of this as you can.
That's great. That's great advice and great insights. I totally see where we're going to have to meter that, optimize that, understand what the trade-offs are. We have some tools where we do that LLM monitoring, token consumptions. We look at, the performance of the LLM, the precision, the groundedness, hallucination rates. We look at a whole bunch of those things, looking at the drift. And if I told you this story where I had a Claude project creating documents for me, reports for me, and I
Yep.
had very specific instructions around how it should format something. I'm very picky about, 1.2 lines between each, line, and then 3 point after every paragraph,
Yeah.
blah, 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 right? Certain fonts and colors and et cetera. And I started to notice that it was starting to slightly diverge. And it wasn't until the 3rd report that I realized, hey, you're not exactly following the formatting. And I said, why are you not following the formatting? He goes, oh, I skipped it. What do you mean you skipped it?
Yeah. Welcome to non-deterministic systems.
It said I got absorbed in the problem and I forgot about it, so I skipped it. Or I didn't pay attention to it. I thought of it as downstream and that I just didn't get back to it. And I'm like, but it's in your instructions, right? It's in the knowledge. It's a rule. Ask you to do this. This is required. Are you telling me that I can give you specific rules and that you may not follow them? And it said yes.
It's true.
Yes. And
Yeah.
and it was crazy because it's like,
Yeah.
but I'm telling you to do this. And it's like, yeah, but it was not statistically as relevant as the other stuff. Like all the problems it was dealing with, I did absorbed in the problem, right? And it thought, okay, that formatting it's almost like giving a problem to an employee and they work really hard on this and they didn't get the font right and they didn't get the heading right. And I give them a hard time about that. And they go, Seth, what are you talking about? Come on, I created this great report and you're picking on the fonts, right?
Yeah.
And
That's what your
it's
AI
like,
is telling you right now. It's
that's what the AI is telling me. What are you doing? Right? You're picking on me for something trivial. But it said that was statistically less relevant. So I think that's so interesting and so critical to think about how that drift works and how we have to really monitor that and be aware of it, along with the token costs and along with all of these things.
So I'll give you an
Yes.
example just to circle back. Attribute-based access control to your
Yep.
data is a system that won't allow
Right.
hallucination because
Right.
it won't allow you to touch data you're not allowed to touch,
Right.
right?
Right.
So we need more of those
That's
guardrails.
right.
Like for the first 2 years, 3 years of GPT, we were being subsidized and we were getting way more value than we were paying for,
Right.
obviously, right? That has changed. Mark this down, April 2026. You are
April
paying
20.
2026. You are paying in one of two ways. You are either paying tokens now and it's a meter and it's really expensive and you can't control it really because of what you just said, which is models are going to go regenerate stuff. If you're using agents, you have to use the API and tap count tokens, full consumption model. Today, I got the email from Microsoft that says full consumption model on Copilot going forward. So they're moving from subscriptions to consumption. The other way is you're going to pay and lock in. So they're still going to give you the max subscription, but you're going to be using Claude directly. So you're either paying in lock in or you're paying in tokens, and you better pick. The third opportunity is to own your own AI and use open models and build your own infrastructure. And that's what I think enterprises are going to be faced with doing with these as they're looking at options here.
Mm.
And luckily, open source, I started my career essentially in open source at Red Hat. Open source is going to be the exit route that gets enterprises to be able to own their own
Yeah.
AI and they can keep their data without having it to go out to be trained because that's the lock-in problem. They can invest in infrastructure and own their own AI. And I think that's really where enterprises are going to have to go unless they're comfortable with unbounded variable costs or lock-in. My guess
But
is
it
they'll
is
have
a
a good
lock-in.
answer. I
What's
mean,
that?
it's no different than SaaS, really,
Yeah.
from
Yeah.
the perspective of running your entire business on a software as a service from the past, but it's more powerful. And that's what I get concerned about is like you are now giving the keys of your IP to, if you're going to be locked into one of these models, you're giving them how you make decisions. Do you really want them to know how you make decisions? That's
Yeah.
that's the wisdom that you've
Yeah.
generated being in your
Yeah.
industry. And that's what you're giving them. So that's one of the reasons we're like, okay, this is a inflection point. It's one thing
Yeah.
to have your customer data in there and your transaction data. It's another to give them your IP of your brain.
Yeah. What about where there's the assurance and you're setting don't train your model with my content? Where does that fit in with this?
I'm not a sky's falling guy. I use Google all the time. Google
Yeah.
knows more about me than my wife
Yeah.
does, very, very
Yeah.
likely. And
Yeah.
so I'm not trying to be all big tech is bad. I'm
Yeah.
just saying if I'm an enterprise, what is it that I own in this day and age?
Yeah.
I
Yeah.
own how I make
Yeah.
decisions. And that's
People.
proprietary
Yeah.
for me. Which data do I use to make the decisions? And if we are just going to give that away, I don't know what
Yeah.
we're doing. That's like
Well,
giving our brain away.
I agree. And I think that consumers of these tools don't realize how much these models know about them. Like if I ask Claude to describe my thought process or my thinking process or my writing process or my voice, it'll give me all these weird attributes. Think of it this way. It's taking a mathematical model that is incredibly complex and it's flattening it out and making something that's n-dimensional, thousands of dimensions, really just a few dimensions. Because what it's saying is, I can't take that mathematical complexity and nuance and translate it into human language, right?
Wow.
It's impossible to do that because language is ambiguous and it's an approximation, right? It's a shadow of what this real understanding is. And you can't describe it in human language. You can't describe it in English. It defies it.
It's
right?
almost like it's subconscious, right? It's kind of the same reason you can't describe sort of the essence of you in human language. It's
Yeah.
subconscious.
And it's tens of thousands, hundreds of thousands of dimensions that describe this. And if you say, give me the characteristics, it is a very, very crude approximation. It does a really good job of emulating my voice and my tone because I give it all of my stuff. I give it all my articles, my book, my podcast, my webinars. I give it everything. Of course, I'm saying don't train your model with it, but
Right.
train my model with it so that I own some of it. But even that is not going to be portable, because if I ask it for a brief or I ask it for a synopsis for another model or for another project, even locking it into a project is problematic, right? Because we have fragmentation in projects. And there's lack of visibility to projects. I think a big problem is how do we take even MCPs? MCPs are approximations because it's trying to build attribute models for things that are described in many, 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 many more attributes than you can define, right? So think about what that means in terms of the ability to manipulate someone, the ability to convince someone of something, the ability to change somebody's thinking or to influence their thinking, right? I just did a series of prompts, Substack, 30 questions that you answer on paper, pen and paper. Then you feed them into a project. Then you have 10 sets of prompts that ask, and these questions are hard questions. They're very introspective,
Thoughtful, introspective.
very thoughtful questions, very difficult. Some of them are inherently contradictory, but then it asks all these questions, about those answers. And it kind of blew my mind, right? Because it really made me rethink like the decisions I'm making, the direction I'm going on, my path, my value, right? I mean, it was so incredible how much this influenced me. And think about that. Think about the implication of this.
Well,
people are giving up more than their name and address and their credit card number.
I'm a huge fan of what it can do for us as a species, right? But if I'm at a company and I'm trying to maintain shareholder value or grow shareholder value, and I'm making decisions to give all of that context. One is, what if I could have all that context and then mine it for better decisions myself? Now I'm onto something, right? Now I can make my business twice as fast or twice as profitable or whatever. I can make my people act like 2x, right? From an efficiency perspective, all those positive things. But I need to own that. And I think at the end of the day, there's a real inflection point for humans and companies and organizations. It's like, what do you own or what are you going to give away? Because right now we're on a path to give it all to $1 trillion big tech, who then has a capability to basically take all the industries. I mean, you saw last week, Anthropic had some, it was all over LinkedIn, 20,000 lawyers showing them how they can basically already do everything that Harvey can do. Really? Like, how do they have that? Well, they have it because everybody's putting all this stuff in there. Right. And so I think as a business decision maker, you really have to understand what you're doing here.
Yeah. And there's so much more we could talk about. I know you're working toward the open decision evidence specification. Can you give us a quick thumbnail of what that is? Why does the industry need that shared standard?
There's a whole set of standards that are needed around AI. And open standards, I think, tend to give regulators and people who are being regulated, companies being regulated, certainty into what they can go do next. And there's a lot of uncertainty around AI. So that's ultimately, open standards can provide some level of certainty so you can move forward with this technology. And the decision evidence specification is just our little contribution to that. There's a lot more that needs to be happening around agents and delegating authority and all these things and the legal frameworks around that. But the decision evidence specification is something we know well from our work in government and intelligence. And so we thought that would be a good contribution out to the world. And we're working with both healthcare and finance organizations to try to figure out how to kind of get that out in the world and see where it goes from here.
Todd, this has been wonderful. I really enjoyed the conversation. Thanks for helping our audience understand why that architecture matters, why that federated architecture. And to our listeners, thank you for tuning in to the Early AI podcast. Be sure to subscribe for more conversations about how AI is shaping the future of business. Thank you, and we will see you next time.
Thanks, Seth.
Thank you for joining us on another deep dive into AI innovation. Tune in next time when we introduce another industry expert and discuss how to maximize AI in your world. The Early AI podcast is sponsored by Early Information Science and Vector. To learn more, visit early.com. That's EARLEY.com. Thank you for tuning in.